Here I'm going to briefly describe our electroencephalogram text-to-speech interface circuit, or EEG TTS. So starting with the dry active probes, we have a headband here. There's two probes that mount on the forehead and one probe that mounts in the back in the PZ region. So here we have spring-loaded headers, kind of hard to see there. They're kind of springy for comfort. It turns out they're not really that comfortable. And then we're using 3.5mm stereo cable to run the brain signal back to our signal conditioning block. So we have our measurement probe, our reference probe, and a ground probe. The ground probe is just used to make the DC potential of user's scalp be the same as the circuit that we're using. So the signal then comes in through here, which is an instrumentation amplifier with a gain of 2. It has a integrator in the positive feedback loop of the difference amplifier, and that will remove DC potentials that would be present on the user's scalp. Then the signal comes along here and goes into an amplifier with a gain of 33, and then into a low-pass filter at a cutoff of about 100 Hz. And then into another amplifier of a gain of 33 as well. And then the signal comes along here, goes into our ADC. It's a 16-bit ADC by Texas Instruments. Has a sampling frequency of 500 Hz, and we apply a gain of 12 here. And I think the final gain on our system is about 15,000. The samples from the ADC are passed through SPI to the PIC16F886. In here the data is structured and buffered and sent through a UART communication to the FTDI chip, which will then communicate to the computer over USB. Here we have voltage references for our ADC, so we have plus and minus 2.5 volts. And over on the computer I have an image of the type of brainwave that we're looking for. So here we have the ideal ERP. This P300 wave is what we are looking for, and we're able to measure this with a single probe. It's common convention to graph these upside down, so positive is down and negative is up. And if I go over here, I have results from our earlier experiments. A stimulus happens at time t equals 0, and here we can see the P300 wave happening at 300 milliseconds. The blue is an average waveform of when there was no stimulus, so we can see the difference there. This is how we are measuring the brain waves. We have a reference probe, a measurement probe in the back, and a reference probe in the front, and a ground probe here. That's in like front of the face. We're assuming the mental activity that creates an ERP can be modeled as a dipole, and it works relatively well for our application. I'm just going to go down and show a little bit. This here is our circuit diagram. We have power supply, dry active probes. Signal goes into the signal conditioning block where those instrumentation amplifier gains and filters were. ADC, communication to the PC. We do some DSP on it, and basically use correlation with an ideal ERP to detect when there was a stimulus. And then that controls our GUI, which will query a database and use suggested words and things, and then it'll speak it. So if I go down a bit, I can show, this is basically what our GUI looks like. There's a bunch of different options you can choose. Each one of these options here, so there's letters, numbers, common sentences, word suggestions, and a sentence builder. So each section will be highlighted, and the user will just basically look at one of the sections, and then it's flashed. Each option is flashed 5 times. We average the signals that are acquired after each stimulus and find out where an ERP existed. And then when, like for instance, if the letters was selected, it'll go into the letters section and it'll start highlighting rows of the letters, and then do that 5 times, average the signal, find out where an ERP was. So if I was looking at M, it would then use the M row, and then it'll go in and highlight all the columns. And then whatever one we're looking at here, if it was M, it would select the M and then put it in here. Also, once it's put in here, over here in the word suggestions, all the words that have been used before that start with M will be brought up here, and the I guess, overall choices that you can make, the outer ones. You could then select word suggestions and select a word. You could also go in here into common sentences and say something that you've said before, which will help speed up our word selection. Here we have something that will basically calibrate the system to each user that uses it. Those ERP waveforms are unique for each individual. So basically what we do is we have this little box here, and it's grayed out, and then it'll flash red 5 times, and then we average those when it's flashed and create an ideal ERP that we can correlate with the incoming samples and see if there's an ERP there. And just some database stuff, we were able to export any data that was taken during the trials. Any database information can be backed up for future use. And that's about it.